Hello friends, welcome, and today we are going to discuss this problem where we are climbing a staircase and it takes n steps to reach the top. So there is an option that either we can take one step at a time or two steps at a time. So only two options are there, and it is asking us that how many different ways we can climb to the top. So let us try to understand what is the intuition here. So intuition is, let's say, if we are calculating, so we can either take one step or two step. So let's say if we are at nth step, okay, if we are at nth step, we might have come from n minus 1th step, or we might have come from n minus 2th, n minus 2nd step, n minus 2th step, right? So we might have come from both these, and how many ways are there for coming from n minus 1th step to nth step? Only one way, and n minus 2th step to one step. Like if we take two steps, like there is one way. So yeah, so either we took one step from here or two steps for here. These are the only options, and then recursively we can figure out like how we came to n minus 1th step, and we would have our base cases. Like for going to 0th step, there is literally no way, and it starts from 1, so it does not make any sense for 0. But if we okay, so for 0 step there is one way, so there is only one way of going, like, which is no way, right? And for coming to the first step, there is only one way, like only one step, okay. And for second, we can come from first or second, so there would be from 0th or first, so there would be two ways like this, okay, 1 plus 1 and 2. Okay, with this intuition, let's try to solve this problem. Okay, so here I am creating a new private method. We would come to know why I am creating this now. Okay, and we would pass this integer n here, and we would call this method from here. Okay, you return from here, let's say. So here what we will do is we will write down the base conditions. So if equal to 1, so in both the cases we would say we would return only one way. Okay, now with else condition we would say that there are two possible, we might be coming from two back steps. So let's try to do that, get. Okay, so we might be coming from these two steps. Okay, so with this I think like we are fine. Try to run it. Okay, this run fine, but there is a problem with this, because we are so let's say if our condition, let's say if the n can go up to 45, so when we keep it increasing, we are getting like more and more cases, and these more and more cases like would be calculated again and again and again and again. So that's a problem. So what we should do here is we should use dynamic programming, which means we should store these values here, and for that, and that's why I created this new function, so that we can use it. So let's say we pass dp here, or maybe let's call it memo, right? It's also called a memoization technique. So we would have memo, and we would initialize this with n plus 1, okay, because we are starting with 0, and if n is n, then probably we would need to iterate up to nth element. So that's why we are starting with n plus 1th, so that we can put that nth element here. And Okay, so here what we can do is we can also start accepting memo here, and we would here also means before every return statement we should store that value what we are returning, and we would return. Okay, here also we will do the similar thing. We'll copy this and we would return memo. Okay, one more thing, while calling these methods again and again, we have changed this definition, so we would also pass on memo here. And okay, so if our value is readily available, we will not go into this whole process, and we would return from there itself. If there is some value there, we would just return. Okay, and that would avoid all these calculations and computations and recursions. Let's try to submit it. Okay, what's the problem? Oh, let's try to submit it again. What's the problem again? Line number 7. Oh, okay, here we are able to compute it in 1 millisecond, which is like 100 percentile. Thank you everyone, see you in the next one.